Hi, and welcome to Lesson 7.3. The title of this lesson is Partial Fractions, and the goal today is for us to be able to take a rational expression, such as this one, and break it up into pieces which, when you add them together, add up to this. As we go through this lesson, I have a procedure that I have typed out here. I'll try and explain really well while we're going through it. It's included in this chapter because part of the process is solving a system of equations. So let's dive into this one for just a minute. We have the rational expression 3p minus 1 over p squared minus 1. And the first step in the process says that we should factor the denominator and write two fractions using a and b as variables in the numerator, because we won't know the numerators. We will, however, know the denominators because they will be the factors of this thing. So I would ask you to remember how you factor p squared minus 1. And many of you are already ahead of me. That's a difference of squares, so we get p plus 1 and p minus 1. Those will be our two denominators. We don't know the numerators. That's what our job is, to find out what those numerators will be. Or the next step is to multiply through by the lowest common denominator of all the denominators. And folks, that would be the denominator, p squared minus 1. So we're going to multiply through everywhere by p squared minus 1. That's totally going to get rid of the denominator over here, 3p minus 1, because that will cancel itself out. Here, we got to just think, okay, this is the p plus 1, but we need to get this into it. So we got to say, okay, it's going to be a times p minus 1. We have to multiply this numerator by the part of the denominator it didn't have. Same thing here. B is going to get multiplied by p plus 1. Now we've gotten rid of the denominators, which is good. No more fractions. It says next that we should simplify the right side, and that's here. So we're going to distribute a little. 3p minus 1 equals ap minus a plus bp plus b. Now it says this, and I had to read this one a couple of times when I was learning this. Write both sides in descending powers and equate, it says, coefficients of like powers and constants. I get the descending powers thing, and this is already that way. So 3p minus 1. Then the p terms we want to write up front. We have AP plus BP. And folks, I would say to you, you can factor a p out of both of those. They both have a p to give up, and that would leave you with a plus b. So we've just taken those two terms, combined them, and factored the p out of them. Then we have minus a and plus b. All right, here's the deal. This is an equation, so the coefficient on p has to be equal. That is, we're going to next write a system of linear equations based on this. That coefficient, 3, has to be the same as this coefficient, a plus b. So here comes our system of equations. A plus b has to equal 3. Okay, again, that has to equal that because we have an equal sign. The next part, the constants, negative a plus b, that has to equal that, negative 1. And here's our system of equations. When we solve this, we'll have the values for a and b that we need. So we're going to add, because we can already eliminate the a's. 2b's will equal 2, and b will equal 1. Once I know that, then I substitute back up in here. And if b is 1, then a must be 2. Cool. Now we've got what we need to complete that expression. So the last step says write the partial fractions using our values for a and b. So we're going to just write the new equation. I'm going to switch colors because this is the answer to my problem. 3p minus 1 over p squared minus 1 is the same thing, or has the same value as, it's a, and that goes over, so 2 over p plus 1, and then plus b, and b was 1 over p minus 1. And what we've done, again, we've taken that rational expression and broken it up into pieces that when you add them together would get you back here. Right? That's kind of a cool thing right there. And it's very new. This is something that I don't believe any of us will have seen before. Now we're going to look at a couple more examples of different types of problems where you can do the same thing. In this type problem, we have a factor that's repeated in the denominator, so we have to handle that a little bit differently. This is going to break down into 3 partial fractions. And the denominator, since this is already in factored form, one of them will be x, one of them will be x minus 1, and the last will be x minus 1 squared. So once we're here, then the process is the same as before. We're going to multiply through by the LCD. And in this case, I guess we would have put our A, B, and C there. That would be, we're multiplying by x times the quantity x minus 1 squared. Over here, we just get x plus 2. The A had an x already under it, so it needs to get the x minus 1 squared with it. A times x minus 1 squared plus B, it already has one factor of x minus 1, so it needs to be x and the second factor, so B times x minus 1. Then C, that's the easiest one because it was over the x minus 1 squared. It just needs to get the x with it. And we've done the eliminate the denominator part. The next instruction says simplify on the right. So we have to do some multiplication here. X plus 2 we leave alone. But this A is going to multiply whatever that is when you multiply it out. So if you're a FOIL person, that will be x minus 1 times x minus 1. And that multiplies to x squared minus 2x plus 1. The next one, bx, has to get multiplied to both of those things. So we're going to have a bx squared and a minus bx, and then we have a plus cx. All right, we have to distribute here. We're still not simplified. So x plus 2 will equal, and it is ax squared minus 2ax plus a plus bx squared minus bx plus cx. The next step calls for us to write the powers in descending order. So that we can equate what goes with what. We have an x plus 2 on this side. The squareds are the two highest powers, so those two have to get together, and we can take an x squared out of them. X squared times a plus b. The next highest powers are these things that have just an x with them. Each of those terms can give up an x. And then the coefficients were minus 2a minus b plus c. And that leaves us with a is the only thing that didn't have an x with it. So now we have our powers in descending order, squared, 1, and none. And it's now we match things up. We're going to write our system of equations. And you'll notice there is no x squared term over here. So since there is no x squared, a plus b must equal 0, because there wasn't any x squared to match that with. X has a coefficient of 1, so negative 2a minus b plus c has to equal 1. And the constant 2 has to equal a. Well, that's kind of good news, because that means solving this system will not be a hardship. We already know one of the values. A is 2. That means that b must be negative 2. since together A and B have to add up to 0, we have to find a C. Negative 2A's, so negative 2 times 2, minus a B, which is negative 2, plus a C equal 1, and that's negative 4 plus 2 plus C equals 1. That's negative 2 altogether. And so now we're adding 2 to both sides, C equals 3. We now have our coefficients, or our numerators. They are not coefficients, but numerators for our partial fraction. So here comes our answer, and again I'm going to write the answer in a different color. X plus 2 over the quantity x times x minus 1 squared will equal A, which is 2, over x, plus B. Actually, we can go minus, since this is a negative, minus 2 over x minus 1, and plus 3 over x minus 1 squared. Our last example has a quadratic factor in the bottom, and it is one that does not factor. If you check that in your head real quick, you'll know that there's nothing that multiplies to 2 but adds to 1. So with quadratic factors, we have a different way to set up the partial fractions. There will be two pieces, one with each denominator, an x plus 3. Again, this is already as factored as it could be. X squared plus x plus 2. The difference comes in the numerators. We're going to put A here, and this piece will be bx plus c. Okay, from here the process is the same. We're going to multiply by the LCD, which is the denominator of this thing. And you guys know the drill by now. On the left side we'll have 8x squared plus 12x minus 20. On the right, when we multiply here by this, we're going to get A times this part, x squared plus x plus 2. On this side we're going to have bx plus c, and that's going to have to be in a parenthesis because it has to be multiplied by this x plus 3. So we have a little bit more of the whole multiplication to do, but after this it's the same as the rest. So we're going to start simplifying on the right. That's going to give us ax squared plus ax plus 2a plus, and now we have to do either FOIL or the box method, whichever you choose. Bx times x is bx squared. Outsides are 3bx. Insides are cx. And last we have 3c. Now we're going to rearrange so that we get into descending power order. And the left side is already in that format, so that's fine. But here are the things that have a squared with them. So x squared is going to get multiplied, or what we're doing is joining these and factoring out an x squared. So it's going to be a plus b. Now we have to look at the things that have an x in it, and we have 3 of them. So x goes with a plus 3b plus c, and then we have 2 constant terms, so it's going to be 2a, we kind of leave those alone, plus 3c, but both of those I'm going to put them in a parenthesis because that's going to be our constant. Now we write the system and solve it. So our system is a plus b has to equal 8. A plus 3b plus c has to equal 12. And 2a plus 3c has to equal negative 20. Now this system's going to be a little bit different to solve, but this is already missing a c. So if we could join these two so that we can get rid of a c, that would be a good idea. And we can do that by multiplying here by -3. Okay, so I'm going to go ahead and do that. -3a minus 9b minus 3c will equal -36. And we want to join that with this one. 2a plus 3c equals -20. And what we'll end up with there is -a minus 9b equals -56. Now, here's one with an a and here's one with a -a. So I'm going to bring this guy down here and then we're going to combine. A plus b equals 8. -8b will equal 56 minus 8, so 48, -48. And 8 times 6 is 48, so b is going to equal 6. Once we know b, we can find a real quickly because b plus a are 8, so a will equal 2. And now we can find c because 2 of our a's, so 2 times 2 plus 3c has to equal -20. That's 4. And subtracting 4, 3c will equal -24, and c will equal -8. So here comes our final answer. I'm going to write it in a different color again. We have the left side, which was 8x squared plus 12x minus 20 all over x plus 3 times x squared plus x plus 2. Folks, that has to equal. Now we got to have our a, that's 2 over x plus 3. And then it is plus bx plus c. So plus 6x minus 8 over x squared plus x plus 2. And that's our final answer. We've decomposed that rational expression into two partial fractions. That's a interesting application of solving systems, and I hope that you will get out there and try the U-Try as quickly as you can, and we'll talk to you in school.